All right, so here we're going to have two pretty quick videos on two different types of inequalities. The first type is a linear inequality. That's what the first video will be on. So there's two different ways that we can graph linear functions. The first way is to graph it from y equals mx plus b. And if you guys remember, what you do is you plot the y-intercept and then plot the slope and graph the line like that. This example that we're going to be doing is in standard form, so the way we graph those is to come up with the x-intercept and the y-intercept. So start with the x-intercept, and remember what you do with that is you're going to plug in 0 for y and then solve for x. So the boundary line that we're trying to graph looks like this. Step 1 is we want to graph just the boundary, so that's the line x minus 2y equals 4. The whole inequality is going to be the full shaded graph that we come up with. The boundary line itself is just going to be this line. So we know how to graph this line from a previous section. So again, start with the x-intercept, which means we plug in 0 for y and solve for x. So it'll be x minus 2 times 0 equals 4. So since we plugged in a 0 here, this is just 0. And so we have x equals 4, that's the x-intercept, and then we can plot the y-intercepts, so we do the opposite for that. We plug in 0 for x and then solve for y. So 0 minus 2y equals 4, so since that's a 0, this is just a negative 2y. Make sure you keep that negative. Then to get y by itself, we can divide both sides by this negative 2, and so we end up with y equals negative 2, which is what that reduces down to. So the x-intercept and y-intercept, remember all you have to do is just plot those 2 points and then you can connect the dots. So x equals 4, that's my x-intercept right there. Oops, sorry. And then y equals negative 2, so that's right there. Okay, so I'm going to connect the dots. I'm going to connect the dots just like that and make a line connecting those 2 points, but I need you guys to look carefully at the inequality. Two things will happen here. Thing number one is if this is just a less than or just a greater than, you're going to draw a dashed line, kind of like doing an open circle. So that's what we have here. So we're just going to draw a dotted line connecting the dots. You do not graph a solid line unless this has an or equal to. So if it has an or equal to, you do a solid line. If it does not have the or equal to, then you do a dashed line, just like we did here. So dashed versus solid, you got to be careful with that. And then the very last thing you're going to do, because now we shade, you want to shade everything less than. So it could be everything above or it could be everything below. But what we do is we do a test point. Okay, so this is super important. This is the last step, is we're going to do a test point and figure out where we need to shade. So the easiest point to test is just the origin. So basically either everything above the line is going to be true or everything below the line is going to be true. Just because this is a less than doesn't mean it's below. That catches people all the time. That'll trick you if you're not careful. So we're going to test the point 0, 0. So now 0, 0 either is or is not part of our solution set. That's what we're going to find out. So plug in 0. Is 0 minus 2 times 0, does that turn out to be less than 4? And so we're just doing like a true or false check. So this comes out to be 0. 0 minus 0. So is 0 less than 4? Yes. That is true. So what that means is that 0, 0 is part of our solution set. Okay, so because the 0, 0 is part of our solution set, everything above this line is part of the solution set. So I'm going to shade the whole thing. Sorry, I was just grabbing a crayon. So everything up above this line is going to be shaded. If this turned out to be false, like if 0 wasn't less than 4, or if you came up with a false statement, that would mean that 0, 0 isn't part of the solution set, so you would shade the opposite. Okay, so let me just recap what we did there. Since this was in standard form, we graphed the boundary line by plotting x and y intercepts. Because this is just a less than and it didn't have the or equal to, we plotted a dashed line. It would have been solid if we had the or equal to. And then we did a test point. The origin is the easiest point to use if the graph doesn't cross through the origin. So we wanted to see if 0, 0 made the inequality true or false. It turned out to make the inequality true, which means I shaded in that direction. If it made it false, I would shade in the opposite direction of the point 0, 0. Okay, let's do a word problem here. One tutoring company advertises it specializes in helping students who have a combined ACT score, verbal and math, of 900 or less. Write an inequality to describe the combined scores of students who are prospective tutoring clients. Okay, so we've got verbal score, so we're going to set up two variables. V for verbal, M for math. That makes sense. So when it says combined ACT score, that's like a sum, like you're adding them together. So the SAT verbal score plus the ACT math score, 900 or less. So that sum is either less than 900 or equal to 900. The reason you know that you have the or equal to is because it says 900 or less. Not just less than 900, but it includes the 900 because it could be 900 or less. So this is part of what we're doing. That's part of our answer. They want the inequality. Next it says it doesn't say to graph. We're going to graph it anyway. Sorry, it says let X represent. I changed our mind there. V for verbal and M for math. But when we go to graph it, we're going to want to know which one's X and which one's Y. Okay, so we are going to set this up so we can do intercepts. So we're going to start with our V intercept, which remember is technically your X intercept since we used V for X and M for Y. Plug in 0 for the other one. So V plus 0 is equal to 900. Okay, and then the y-intercept, remember that's the same as m. Plug in 0 for v and solve for m. Okay, so both the intercepts are 900. So let's scale it by 100. So 100, 2, 3, 4, 5, 6, 7, 8, 900. Okay, so on the x-axis we're putting v, the verbal scores, and then on the y-axis we're putting the math scores. So 100, 2, 3, 4, 5, 6, 7, 8, 900. So right there. Okay, so we're going to connect the dots. This says less than or equal to, so that means you're going to connect it with a solid line. Like, whoops, sorry, should have been a little straighter. I'm trying to connect that dot. So it looks like that. And then next what we're going to do is figure out where to shade. So we're going to test the origin. So we're going to see if the origin makes this inequality true or false. So does 0 plus 0 come out to be less than or equal to 900? And that's a yes. 0 is definitely less than 900. So we're going to shade below, but here's the thing, since this is a story problem, we're actually not going to shade everything below. We're just going to shade up to these lines. The reason is you can't get less than a 0. Can't get a negative score on the verbal portion, and you can't get a negative score on the math portion. So this 0 is the lowest math score that you can possibly get, so I don't go any farther than that. And this 0 is the lowest verbal score that you can possibly get. So it actually turns into a triangle rather than like a whole shaded region. All right, so that's it for the linear ones.